All right, so the first one, you guys got it right. You can plug in a 4 here. What is 4 squared? 16 minus 16 is 0. This works. We can include 4. Can we include a 5? Yeah, you'll get 25, and this will still be positive. As long as we have numbers bigger than 0 underneath this square root symbol, we're good. So we can do numbers bigger than 4, and we can also include 4. Thumbs up if we're okay with this so far. Okay, now I noticed some people, not everyone, just a few, we were a little bit forgetful. Remember, you can also plug in a -4. What's -4 times -4? It's also positive 16. Minus 16 gives you that 0. So you should also have -4 over here. Now, let's think for a moment. Can we plug in a -5? What's -5 times -5? A positive 25. So going this way, we will also have positive numbers under this square root symbol. Okay? So this is your domain. This is the domain. I'm going to show you what this graph actually looks like so you can visualize it. I'll pause here and pull up. That's what the graph looks like. On the left, it goes all the way to the left. It stops at -4 for a little bit. So it goes this way, negative infinity. Oh, that's a -8. It goes from negative infinity all the way to this -4. It takes a break, and then it goes from 4 to infinity. That's what the graph looks like, okay? All right. Now, before we get started today, I want to show you guys some different graphs that we also know the domain of. Everyone in the air, can y'all draw the square root graph? Draw it in the air. Good, Erica. Good, Kelly. Y'all got it. Okay, so this is the square root graph. This is a square root graph. Anytime you put an even root here, so let's say I put a 4 right up here. Let's say I put a 4. It still looks quite similar. So your domain and your range don't change. Let's change this to another even number like 6. It still looks similar. 8. So guys, even roots will look like this. Even roots. Okay, 20. That's also even, looks like that. Okay? Now let's do odd ones. Let's do odd. So let's get rid of this. Here's an odd root. That's what that looks like. If I do another odd root like 5, looks very similar. That's what odd roots look like. Okay? Now let's look at some more graphs. Everyone go ahead and draw a quadratic in the air. Very good, Preston. Good, Alex. All right, we all got it. A quadratic looks like this. It's a U shape. Anytime you have an even one, that's the 4th power. X to the 6th will also look very similar. Okay, we guys get it? What does a cubic look like? Draw it in the air. Do it again. What? Do it again. There we go, Kinley. Okay, so this is what a cube looks like. That's what a cubes look like. Okay, a cubic looks like that. Any odd power will look very similar. So if I change this to a 5, looks very similar. So guys, what's the domain and range of this? All real numbers, okay? All right, so your domains will pretty much be just like the parent functions. Today, we're going to be doing operations with these functions. So if I'm doing addition, you can also write it as f of x plus g of x. These are equivalent. Subtraction, you'll see it written like this. You'll also see it written like this, f of x minus g of x. Multiplication, you'll also see it written like this. Be familiar with both of these. F of x divided by g of x. There's 4 operations: addition, subtraction, multiplication, and division. This is how it will be notated. Okay, let's look at an example. Okay, so we are going to add these functions together. So f is x squared plus x, and I'm going to add g of x, which is 3x minus 1. We'll just combine these. So this will be x squared plus 4x minus 1. This is our new function after we've performed the operation of addition. Please tell me what the domain is. Yes. The domain is from negative infinity to infinity. How do we know this? Because it's quadratic. And we just looked at the parent function. The parent graph looks like this. Now, of course, it was transformed a bit, but the domain is still pretty much the same. Make sense? All right, let's look at subtraction. So we have x squared plus x. We are going to subtract g of x. Whenever you are subtracting, you need to put it in parentheses because we will distribute this minus sign. So I will get x squared plus x minus 3x plus 1. We'll combine this middle portion. So I'll get minus 2x plus 1. This is my new function. And again, what is the domain now? It's all real numbers. Oh, what did I do? Here we go. All right. Now, let's talk about multiplication. Now we're going to multiply these. So I have x squared plus x times 3x minus 1. So I'll do the first one. X squared times 3x is 3x cubed. X squared times a negative 1 is a negative x squared. Next, x times 3x is 3x squared. X times negative 1 is negative x. Combine the middle. So my answer will be 3x cubed plus 2x squared minus x. No, you don't have to. Okay, so this is my new function. What is the domain? All real numbers. Because guys, the parent function is x cubed, which looks like this. Okay, so this will look similar because it's cubic. So your domain is also all real numbers. Okay? Now, this is where it's going to get a little bit tricky whenever we do division. Okay? So let's set up the division. We'll have x squared plus x in the numerator and 3x minus 1 in the denominator. We're dividing these two. Now, there is a rule whenever you divide. What can you not do when you're dividing anything? Zero. Yes, you cannot divide by 0. 0 cannot be in the denominator. You cannot have 0 in the denominator. This is a no. You can't do that. So I want you guys to think about what number can you plug in here to where your denominator would be 0. Think about it. That cannot be included in your domain. I'm going to pause here and let you guys try to figure that out. Okay, so what I'm going to do is let's equal this to 0 and solve it. I'm going to add 1. I get 3x is 1. Now I divide both sides by 3. This says whenever x is 1/3, your denominator will be 0. Okay? So that means for your domain, x can be anything except 1/3. Because if you put a 1/3 here, 3 times 1 is 3, divided by 3 is 1, 1 minus 1 is 0. That's bad. We don't want that. Okay, so your domain cannot be 0. Cannot be 1/3. Your domain cannot be 1/3. Now, if you just write this, you will not get credit because this is what I want you to write. I want it in interval form. Can you guys try to write on your paper how you would represent this in interval form? Go ahead and write it down. I'm going to walk around and check. How would you write this in interval form? Okay, so you should have written, you can be anything below 1/3 and anything above 1/3. You just cannot be 1/3. Now, I saw some great questions. Some people asked, why can't this be a bracket? Does anyone have an answer for that question? Yes, Alex?
Because that would make it 1/3.
Yes, exactly. That means it would make it 1/3. We cannot include 1/3, okay? Brackets means you include the number. We're not including 1/3. We just said it here. We're not including 1/3, so it has to be a parenthesis. Okay, now for the challenging question. Are y'all ready? I'll walk you through it, don't worry. Is this one? Okay, well, let's talk about it. Guys, before we start this operation, I want you to tell me, what is the domain for natural log of x plus 3? And what is the domain for the square root of x squared minus 9? Write this on your paper. Give me the domain for each. All right, this one over here, I'm going to pick on someone. Khan, what did you get for the domain over here for this natural log of x plus 3? Perfect. -3 to infinity. Guys, let's see. Ava, what's the transformation that happened here?
Oh, left 3.
Yes, this graph went to the left 3. That means you have an asymptote at -3. That's why your domain is from -3 to infinity. Okay, it starts at the asymptote and it goes to the right. Okay, now the domain for this one. Let me see. Cadence, what'd you get for this? Okay, so that means if I plug in a 0, what's 0 squared? -9, that made it negative. So not every number works. Yes, Luke? Good. Good. Oh, sorry. With a bracket. Good. This one has to be a parenthesis because there's an asymptote at -3. Okay? This one, think about this for a moment. Make sure you understand why these are the domains. Yeah, this one right here is just like the warm-up. It's just like the warm-up. Okay. All right, we're going to come back to this question after lunch, okay? Okay, so we are now going to divide f divided by g. We're going to do f divided by g. So I'm going to have natural log of x plus 3 divided by the square root of x squared minus 9. Now, let's talk about what the domain can look like. I'm going to do a number line. We said for this one over here, the domain is -3 to infinity. So here's -3. You said that we could go from -3 to infinity, right? That's the domain of this top one. Okay, do y'all understand the picture I just drew? Okay, now I'm going to draw the domain for the bottom one. I'll use a different color. I'll do red. You guys said the domain for the bottom can be anything below -3 and anything above +3. Does my picture make sense? Okay, now we want to see where it overlaps. Let me draw this a little longer. Let me draw this a little bit longer. You guys see where it overlaps? That is your new domain. Okay, so your new domain is 3 to infinity. Can you please talk with your partner why I did not make this a bracket at the 3? Why did I leave it as a parenthesis? Please talk to your neighbor and come up with an answer. Okay, so good job, guys. We are not including the 3 because if you plug in a 3 here, you'll get 9 minus 9, which is 0. We do not want 0 in the denominator. So this is my new domain. Is that okay? All right, let's do another one. Guys, this time I want you guys to do G divided by F. Do G divided by F. Ready, go. As you guys are thinking about this is an important fact you have to remember. Natural log of 1 is equal to 0. This is an important fact you have to remember. This will help you determine the domain. Good thinking going on. Okay, so let's look at what this will look like. G of X divided by F of X. Okay, so let's talk about the domain. I'm going to do a number line because that helps me. Here's -3, here's 0, here's 3. Okay. Here's -2, here's -1. Okay, so let's look at this first domain. The natural log of x plus 3, the domain goes from -3 to infinity, right? Okay, let me draw you a picture so we understand. This went to the left 3. And what can you plug in right here so you get 1? -2. So ln, if you plug in a -2 here, we get 1. And what's ln of 1? 0. So guys, that means the point -2, 0 should be on my graph. So -2, 0 is right here. I have an asymptote right here. So this is my graph. Oh, sorry, I messed up. My line needs to go through that point. That's what my graph actually looks like. Make sense? Okay, if you plug in a -2 here, you get 0. So that is the point there, -2, 0. Okay, so let's do the other one. We'll come back to this idea. Let's go ahead and graph this domain. This domain is -infinity to -3. And then +3 to infinity. Do you guys see where it overlaps? Yep, it overlaps right here. This is just a point. That's just a point. That's a coordinate. If you plug in a -2, you get out 0. This is not domain. I'm not talking about domain. This is just a point. It's a location. -2, 0 is right there. And your line goes through it. Okay, so that means your domain. Tell me what the domain is, guys. 3 to infinity, and what will my enclosures be? Bracket and very good. Very good. So this is your domain. All right, so guys, I want you to try example 4. Everyone go to example 4. All right, good discussions. Let's do f divided by g. So f of x divided by g of x. We'll have the natural log of x minus 4 over the square root of x minus 2. Before you do anything, I want you guys to tell me what the domains are. What does this graph look like? What happened? Yes, this went to the right 4. So that means 1, 2, 3, 4. This is what your graph looks like. So what's the domain here? 4 to infinity, parenthesis or bracket? Yes, parenthesis. Okay, over here, what does this graph look like? Right 2, so it looks like this. So this one is 2 to infinity, right? Okay, now let's look at what our graph is. Where do they overlap? Let me do a number line. Here is 2, 3, 4, 5. Okay, so this domain, we said it was 2 to infinity. And I'll do the other one in a different color. This one is 4 to infinity. So open circle at 4 to infinity. Do you guys see where it overlaps? It overlaps right here. So what's our new domain? 4 to infinity is your new domain. But what, do I put a bracket or a parenthesis on 4? Parenthesis, because there's an asymptote at 4, right? There's an asymptote at 4. So it's open circle. So this is your new domain. Okay, now guys, I want you to do g of x divided by f of x. What would that one look like? Okay, so this time we have square root of x minus 2 divided by the natural log of x minus 4. So let's talk about the domains again. Before I start, let's graph this real quick. This went to the right 4, correct? Okay, now let's remember this fact that I told you about. ln of what equals what? ln of 1 equals 0. So what number can I plug in to get 1? Yes. If I plug in a 5, I get 0. So this point needs to be on the graph, correct? Okay, so I'm going to plot that point. I also have an asymptote at 4. So this is what my graph looks like. That's what this ln graph looks like. Okay, that's important. Keep that in mind. Okay, now let's talk about the domain. Here's the number 2, 3, 4, 5, 6, and so on. Okay, so this top domain, your square root graph, it goes from 2 to infinity. The next one, this ln graph, it goes from 4 to infinity. Why am I not going to include 5? Why? Because the denominator cannot equal 0. Look, if I put a 5 right here, 5 minus 4 is 1. The natural log of 1 is 0. The issue this time is that the natural log is in the denominator. You cannot have zeros in the denominator. That is why we have to exclude 5. That would give you a 0 in the denominator, okay? So our domain, let's see where it overlaps. And listen to my voice. It overlaps right here between 4 and 5, doesn't it? It also overlaps after 5. Okay, so our domain, let's write this down together. Our new domain, I'll write it right here. It goes from 4 to 5, and then 5 to infinity. And these should not be brackets because we cannot include 4. You cannot include 5. Yes. Good question. So someone asked, listen, someone asked, why didn't this apply to the last problem we did? Let's go back to the last problem. ln, the natural log, is in the numerator. So it doesn't matter if there's a 5 here. You can have 0 in the numerator. The issue is when 0 is in the denominator. This one? Oh, where it's in the bottom here? Perfect. Okay, let's look. If you plug in a -2, that would give you 0, wouldn't it? That's right here. That's not in the overlapped part. Yeah, very good question. So in this part, yes, if you plug in a -2, it would give you 0, but that's over here. It's not in the overlapped part. -2 can't go in here either, because that would give you a negative. Okay? All right, I'm going to end it here. You guys are going to keep practicing these concepts. That's it. Great job. F of x is square root of x plus 6 divided by the square root of x minus 2. Before we begin, please tell me what the domain of this is. -6 to infinity. This one? 2 to infinity. Okay, so let me do a little number line. Here is -6, here is 2. So this first domain, it goes from -6 to infinity. The second one, it goes from 2 to infinity. You guys see the overlap? Overlaps right here. So it should be 2 to infinity, but I have a question. I wonder if you guys noticed it. Did you do a bracket or did you do a parenthesis? Okay, those of you guys who did a bracket, why did you do a bracket? Because there's a closed circle here?
Wait, no, you can't.
You can.
Nathan, why can't, which one did you go for? Why is this one correct? Why not? Exactly. If you put a 2 right here, what's 2 minus 2? Can you have 0 in the denominator? No. So this is not right. You cannot include 2. This is your answer.